Second page. There's some typos on this page, but not a ton of them. We'll figure it out here. X-Intercepts. That means put 0 in for y. If I put 0 in for y, this equation up here that you have would be x squared plus 4 times 0, which is gone, equals 8. If I take the square root of both sides, I get x equals plus or minus the square root of 8. But that's not an intercept. An intercept is a point, so the x is square root of 8 when the y is 0, because that's what we put in for y. Or it is negative square root of 8 when y is 0. Now the square root of 8, the square root of 9 is 3, so square root of 8 is almost 3. So if I jump over to the graph, I need to go almost 3 in the x and almost minus 3 in the x. To find the y-intercepts, I make x be 0. So if I make x be 0, the x squared is gone, and I get 4y squared equals 8. If I divide by 4, I get y squared equals 2. If I take the square root of both sides, I get y equals plus or minus the square root of 2. I got that when I let x be 0 and y is plus the square root of 2. When x was 0, we could also minus square root of 2. Square root of 2 is about 1.4, so I'm going to go up 1.4 at x equals 0 and down 1.4. And I've got some more points on there. Now, does the graph have y-axis symmetry? Well, if to have symmetry with the y-axis, we got to get the same answers for positive x's and negative x's. So the equation has to be one that doesn't care, gives the same results for x being positive or negative. Well, since x is squared, then the equation doesn't change for a change in the sign, S-I-G-N, of x. In other words, if I change x from a positive 1 to a negative 1, when I square it, they both give me 1. Or if I change it from 2 to negative 2, they both give me 4. So it is symmetric with the y-axis. Again, it's symmetric with the y-axis because it doesn't care whether x is positive. Now, I should have asked over here with the x-axis if I asked for the y here, or I should have asked for the x here and the y here. And I may switch those on the retest, so you got to watch what I say there. I messed that up here, so what I was expecting this one to be is the opposite of that one. So if I'm looking for the x-axis, I need to know whether the equation cares. If it's going to be symmetric with that, it shouldn't matter what the y, if the y is positive or negative, I should get the same numbers for them to be the same over that. So, since the y is squared, then symmetric with x-axis. Now, I shortened it, I didn't say that part, but basically because it's squared, it doesn't care whether y is positive or negative, and it works. How about the origin? Well, in this case, if it's symmetric both x and the y-axis, then it has to be symmetric with the origin. Otherwise, you need to test and see if changing the sign of the x changes the sign of the y. In this case, since symmetric with x-axis and y-axis, it must be symmetric with origin. And we'll see that when we do some points here. Now, a good point to put in might be 2 for the x, because then I'd get 2 squared, or 4, plus 4y squared equals 8. And the only way this would be 8 is if y squared was 1, so y would have to be plus 1, or y could be negative 1. Now, if you put in negative 2, you get identical equation, and so y would be plus 1 or negative 1. Now, symmetry with the origin, if 2, 1 is on the graph, then if I change the 2 to a negative, the y should change. And that's also on the graph. So it's a point across. So if you look at the graph, if 2, 1 is on the graph, to be symmetric with the origin, over here at -2, -1 should also be on the graph. And that happens here. And if I have 2, -1 on the graph, if 2, -1 on the graph, then if I change it to -2, it should be plus 1. -2 plus 1 is on the graph. And so those are across from each other. And that works. And now I got much better information to draw this curve. Okay? Now, some of you put in 1 for x. So let's just see what that does. So 1 squared would be 1 plus 4y squared equals 8. If you subtract 1, you get 4y squared equals 7. You divide by 4 and you get y squared equals 7/4. If you take the square root, you get the square root of 7 over the square root of 4, which is 2. So you get square root of 7 over 2, but you also get plus or minus. Or square root of 7/4 would be all right, plus or minus. But you also could put -1 in and get square root of 7 over 2, and minus 1, you can also get minus square root of 7 over 2. Okay, so I did 8 points. You only needed to do 3 that are different from the original ones. Okay, on to 24. So we have a point at -6, 1, 2, 3, 4, 5, 6, plus 3. That's this point. And we're supposed to determine the equation of a line that doesn't hit the x-axis. There's no x-intercept. It doesn't cross the x-axis. So the only way it won't cross the x-axis and go through this point is it has to go parallel. So what's happening on this line? Well, that's -6, 3 there, -5, 3, -4, 3, -2, 3, -1, 3, 0, 3. The y-coordinate is always 3. So the equation of this line is the y-coordinates are always 3. That's it. 25. It says center at -2, 1. But it says you can write the equation, x minus h squared plus y minus k squared equals r squared. And r is supposed to be 6, and h is -2, and k is 1, so we have x minus a minus 2, or x plus 2 squared, plus y minus 1 squared equals 6 squared. There's the answer. That's just filling in the h and k and r. Now to get it in the other form, we actually have to square the x plus 2. So we got x plus 2 times x plus 2. We have the y minus 1 times the y minus 1. And it's equal to 36 if we add these. So this is foiling. We get x squared plus 2x plus 2x plus 4 plus y squared minus y for the insides, and the last there plus 1 equals 36. Now I'm supposed to put them in this order with the 0 at the end, so I got to write the x squared first, then the y squared, then I got to write how many x's I have, and there's 4 of them. Then I got to write how many y's there are, and there's minus 1, minus 2 of them. And then I got to put all the constants together. So I got 4 here and 1 there. That's 5 on this side already. And I got to subtract 36 over to make it 0. So 5 minus 36 is minus 31. Now I messed up here where these are supposed to be 27 on both of these. So let's do this. I had x squared plus y squared minus 2x plus 10y equals 10. Now just like in this problem, this is 4x, so that meant it was x plus 2 originally, and so the center was at minus 2. Half of the 4 and change the sign. Half of the negative 2 is 1, change the sign, plus 1. So I look at this. Half of negative 2 is 1, negative 1, change the sign, that makes the center at plus 1. Half of 10 is 5, change the sign, negative 5. There's the center. So that means in standard form it had to have been x minus 1 squared plus y minus 5 squared equals the radius squared, which we're still trying to find. If I multiply out x minus 1 times x minus 1, I get x squared minus x plus 1. Minus 1 times minus 1 is plus 1. And if I multiply out y minus 5, I get y squared plus minus 5y minus, oops, excuse me, I made a mistake here. Half of minus 2 is minus 1. Half of plus 10 is plus 5. Oop, oop, oop. So these are plus 5s. So I get plus 5y plus 5y plus 25. And it's addition in between these. And then there's an equal, and then there's the r squared. So I have x squared minus 2x. I have x squared minus 2x. I have y squared plus 10y. Y squared plus 10y. So all of that is always 10. So I can say These that I've circled down here are 10 plus the 1 plus the 25 is r squared. So 10 plus 1 is 11 plus 25 is 36 is r squared. So to complete the equation, I need to and the equation has got started right here. I need to write 36 for the r squared. So I got x minus 1 squared plus y plus 5 squared equals r squared is 36. So I got to write 36. And if I take the square root of both sides, I get r equals 6 or negative 6, but a negative radius doesn't make any sense, so the radius is 6. Now to draw this, 1 over and down 5 would be kind of low on the graph, so I'm going to move my graph up. So I'm going to make the x and y coordinates here, and make each one of these be 1. And so this would be minus 1, 2, 3, 4, minus 5. So 1 minus 5 is there. There's the center. You really need to put units on your graph so that I can tell what you're thinking. Some of you didn't, and you lost points because of that. Then I got to do a radius of 6. So I got to go over 6 this way, which is 1 past the grid. Got to go 6 this way, 1, 2, 3, 4, 5, that's 1 past the grid. I go to 6 down this way, which is 2 past the grid down here. This way is 1, 2, 3, 4, 5, 6, right at the top of the grid. And I got to try to make a circle that hits those points. And there's the key, finished.